Hey, today I'm going to show you all the different texture options available for the N64 using FAT64. If you're new to N64 graphics and haven't seen my previous tutorials, I suggest you watch those first so that you have some basic understanding of how N64 graphics works. You should also probably learn about UV maps in Blender because those are pretty important for texturing. There's lots of tutorials online about that, so I won't go into any detail. So for the N64, the first thing to learn are the different texture types. When you have a texture selected as the color input to the color combiner, FAT64 allows you to load a texture. And you can do that here on the Sources tab. So whenever you load a texture like I have here, it's going to autofill some properties. It's going to tell you the TMEM usage, the size of the texture, and it's going to guess a texture type. So the texture type here is what I want to talk about, and it's going to be made up of two values. So it's going to have the format and then the depth. So we have RGBA 16-bit, so the format's RGBA, and the color depth is 16-bit. So for the N64, we have 5 different texture formats we can use and 4 different bit sizes. We don't really use YUV at all, so you could ignore that. We have RGBA, color index, IA and I, and these two are intensities, textures, which means grayscale. And for each of these, we have 4-bit, 8-bit, 16-bit, and 32-bit. You can only use specific combinations of each, and FAT64 will limit you to these selections. The important thing to look at with color depth is the memory taken up per pixel. The N64 has a limited texture cache of 4 kilobytes, so if you use a larger resolution texel, you'll get less texels in memory at once. Here I have 2 textures. They're loaded the same, but with different texture formats. And FAT64 is going to tell me how much space I use up. This Intensity 8-bit one uses 4096, all 4 kilobytes of space. And the 4-bit one uses half as much space for the same exact texture. Now pay attention to how these both look pretty much the same here, and then compare them to how they look in game. So in game, we see the full effect of having a limited color resolution. The 4-bit texture has pretty intense banding and generally looks kind of ugly, especially with the gradient texture. On the other hand, the 8-bit texture on the left is very smooth. The trade-off is the memory size, like I talked about earlier. You can fit twice as much texture in the same space. Now let's take a look at an Intensity Alpha texture. Intensity Alpha has its own separate alpha color channel. This makes Intensity Alpha textures less precise for their grayscale values at the same bit depths as basic intensity textures. But you get the option of having fine control over your alpha. Here I have an IA4, 8, and 16 texture all in a row, and I'm looking at the grayscale values for comparison. The 4-bit texture looks pretty rough. You can really only see 3 distinct colors. The 8-bit one looks a bit better, though it's still pretty bad. And the 16-bit one looks about how I would expect. This is because we only have 3 bits of resolution on the first, 4 bits on the second, and we have 8 bits on the third. So you can see that on the third one we don't even have a full texture though, and that's because we're pretty limited in texture size, and the 16-bit one is not large enough to show the full texture. The 8-bit one, you can show the full texture, but it's going to take up all the memory, and the 4-bit one is going to only take up half of the memory, so you could load a texture twice the size if you wanted to. Now let's look at how partial alpha is dealt with in both I and IA textures. So for pure intensity textures, the grayscale value is also used as the alpha value. So on the I4 texture on the right, we can see the same banding we saw before when we were looking at just the value. And on the left, we see a smooth gradient because we have 8 bits of alpha as well as 8 bits of value. On the intensity alpha textures, we can see a stark difference in the options. The IA4 only has 1 bit for alpha, so it can only be on or off, and you can see it doesn't look very good. The IA8 texture has 4 bits for alpha, and you can see it's a bit less clean than the IA16, which looks smoother and generally has more gradients and refinement, let's say. RGBA textures are textures with a full color range and what we commonly see with imaging for computers. It's the final output color the N64 uses when setting to your TV as well. There are color channels for RGB and A separately, and any image can be represented with an RGBA formatted texture. So we only have two available bit depths. That's going to be 16 on here on the right and 32 on the left. And these are going to look the same in FAT64, but we can see a pretty big difference when we go to in-game. So in-game, we can see the difference in the alpha and also a tiny bit on the color depth. So RGBA 16 only has 1 bit of alpha, so there's going to be no gradients and no fading away for that one. And RGBA 32 has a full 8 bits for all 4 channels, so we get the most resolution out of any other texture type. Color indexed is a format that uses a limited palette of colors, and depending on the palette type, you choose from a select amount of colors and use those instead of picking any color within the format range. The benefit for this limitation is generally higher resolution and saving memory. The palette for a color index texture can be either intensity or RGBA. Generally, we use CI4 textures and RGBA, and you're going to have 2 common outcomes with that. So you're going to have something like on the left, and it's going to look blotchy because the color depth is too limited. You only have 16 colors. Or you're going to get something on the right, which looks pretty good. You can see a few little limitations of the color, but it's going to be better, and you get the higher resolution image with a full RGBA color spectrum that you're not going to be able to get on RGBA 16. You can make up to a 64 by 64 texture with color index textures, and that's twice the size as a normal RGBA 16 texture. So you'll notice we have 2048 out of 2048 TMEM usage when we select this texture, and that's because half of TMEM is reserved for palettes. You can have up to 8 different palettes, and you only have half as much space for the regular texture. As a side note, you can do CI8 textures, which is 8-bit depths, and that gives you 256 colors, which is enough to display almost anything. And it only takes up half as much size as a 64 by 64, so it's the same size as an RGBA 16 at the max, but it uses up less memory and less size in the ROM. If you select an RGBA 16 texture, almost always FAT64 will default to a CI8 texture because it's just going to save memory. You will have the disadvantage though of being locked into a color index texture, so that will matter a little bit when we get into some more advanced options. On the N64, a texture is displayed on what is known as a tile. You can imagine a texture as sort of an image that is being printed onto a tile, like this square here, and then the tile is arranged in a regular pattern and manipulated based on special properties before being placed on the screen. And it's similar to the UV screen you would see in Blender. So the tile coordinate system works on an S and T axis, which are the horizontal and the vertical axes. Tile units are basically the same as UV units for the triangle, and the texture gets placed in these coordinates in special ways based on the options you select. The max tile size is 1024, which is way out there, and that puts a hard limit on the size of the texture you can use. So you can find options for your tile on the texture selection right below here. The ones that are always presented are the most useful, and that's clamp and mirror for your axes. A clamp is going to stop the texture from repeating at the end of the tile, which is normally just the end of the texture. We can see on the left it's normal repeats, and on the right is a clamp. A mirror will take the texture and flip it on the chosen axes instead of wrapping it around when you get to the end of the texture. And we can see a mirror on the left on both directions and a normal texture mapping on the right. We can edit how these flags behave by looking at the more detailed properties that will appear when you uncheck auto set other properties. And we have 4 per axes. We have the mask, the shift, and the low and the high. So the low and the high coordinates are the tile size coordinates, and the tile size is made up of the difference between high and low. When the N64 maps the texture, it takes the UV coordinates and then creates tile relative coordinates using the tile size, which then go on to tell the N64 which part of the texture to use for each pixel. So if we have a tile coordinate of 31 to 63, then that means we have a tile size of 32 pixels squared, and then it starts at 32. And so if we take something like this and we go to 16, it will offset it by 16. We went 16 to the right. And this works because when we have the UV coordinate of 0, it's actually minus 16 in tile relative coordinates, because it's 16 below where we start, which is 16. The tile size is also going to affect the clamp boundaries. You can see both of these textures are clamped, though this one is clamped at 2 repeats. That's because my tile size is 64 and the texture is 32, and it clamps where I set the tile size. It doesn't clamp at the top left corner every time. It clamps where I start the tile and where I end the tile. Another interesting thing about tile size is that you can edit them and it will move the entire UV basis all at once with no regard for what the UV map is. And this is the principle behind an S/T tile size texture scroll that you have in FAST64. I have one here, and it's going to be moving the entire face all at once just from editing the tile size. So next we have the mask. The mask tells the game which portion or which coordinates to start repeating the texture mapping at. And it's in powers of 2. So if you have 5, you have 2 to the 5th, and that's 32. If you have 6, which is the one on the right here, the default one, it's going to be the size of the texture, and that's 64, and so on. So when you have a mask lower than the texture size, like I have here, that's going to repeat at the boundary that I set. So every 32 texels, it's going to reset, and it does that in both directions. So when you have a mask larger than the size of your texture, it's going to overflow. It's going to read past the boundary. Let's say at texel 65, it's going to start reading something else, because this texture fills up all of TMEM, but it's a color index texture. It's really only the first half. You're going to get some weird behavior, and you're not going to see that in FAST64, but you'll be able to see it in game. So here we have our example of a larger mask than the size of the texture, and the edges get corrupted. Another thing to look at when dealing with the mask is the mirror properties. Mirror is going to mirror at the boundaries of the mask. So on the right we have a 64 unit mask mirror, and it's going to mirror at the same boundary. So we get a normal mirror at the edge of our texture. So for our plane in the middle, we have a mask of 32 texels, so we're going to mirror every 32. And so we could see that it has twice as many repeats. We get 4 repeats of our halved texture. For the one with overflow, it's actually going to allow you to draw the texture twice before flipping. You get 2 draws, then it flips. So when you get overflow, it's going to behave different depending on the type of texture you have loaded. So on the bottom left, I have 2 RGBA textures loaded, and we can see it displays both of them fully, but they look a bit weird and distorted. On the top left, I have a leaf, And on this one, I only did it on one axis, and so it's actually going to look proper and how we expect. It's going to repeat twice, flip, and then repeat twice. So depending on how you use it, it can do a proper effect, though it's kind of finicky and kind of buggy, so you need to watch out if you ever try to use this properly. So the final tile property to talk about is shift. A shift is going to affect the scale of tile coordinates, and it's going to increase or decrease the coordinates by a factor of 2. So here we have the base 1, or the reference on the right. We have a shift of 1 right next to it, and it doubles the size. We have a shift of 2, and it quadruples the size. And I have a shift of -1 all the way to the left, and it halves the size. And here is all of that in game. When you do a shift, it's going to affect everything. So you can see that even though I have a 32 or a 64 on the tile size, it's still going to clamp the same even after I shift it. So it's not going to change your boundaries, it's not going to change your UV coordinates or anything. It's just going to be a final multiplicative scale on how your texture looks. We have some other options we can apply besides tile settings. One is the texture scale. So the texture scale is normally auto set, but when you manually set it, you can choose a number between 0 and 1, and it lets you fractionally scale to a very precise value what your texture size is supposed to be. So on the right or the left, I have 0.25, and on the right, I have a 0.5 size texture scale, and you can see it does a half size and a quarter size just fine. This is going to affect everything evenly, so there's not really much of a reason to use this most of the time, though it can come in handy in specific circumstances. So a pretty interesting interaction with texture scale is the precision on your textures. So in SM64, you have 5 bits of decimal precision on the UV coordinates, and if you scale those down a bunch and then scale them up using a texture shift, you lose all of that, and you end up getting some wacky looking textures. And as you move around in game and around the texture, you'll notice that things are moving around, and that's because the texture units are actually being rounded on the screen. And we can see that effect here. This is really pronounced. I did this just to show it off, but you can see everything is really distorted and it's wobbling around as we walk because the texels do not know where to place themselves on the screen. Everything is at this scale should be single units of precision, so, or even like units of 2, so you know it's getting rounded to the nearest 2 pixels on screen. So another option you have with texturing is large texture mode. You have to click a box right here to enable it, and it'll let you make a texture that's much larger than any SM64 or N64 texture could possibly be. So in order to use this, what is actually happening behind the scenes is that it's taking each individual face and it's cutting a chunk out of this big texture and putting it on that face. So you have to subdivide this so that each little piece gets a small chunk of texture that fits into TMEM. Since this is RGBA 16, I need to do the math and figure it out so that I can get a 32 by 64 texture in here. Generally you want it to be a bit smaller so that you don't get weird boundaries and weird little seams at the edges. When you're using large texture mode, repeats don't work and tile scrolling doesn't work and multi-textures don't work. It's really only to make one big single large texture. So if you do this, it's really only good for making like a background or like a poster in game to show in a small area. But you shouldn't really try any fancy effects with it because it doesn't work well. So the final thing I want to go over with texturing is multi-textures. Multi-textures allow you to use 2 different tiles at the same time, and you can choose to have 2 different textures or use the same texture for both tiles. And both tiles can have a bunch of different flags, all the ones I went over earlier. Though you still have to work with the same 4 kilobytes of texture memory. So in order to use a multi-texture, you have to select both types of texture inside the color combiner. So I have texture 1 and texture 0 selected here. You have to go to the upper section and you have to select 2 cycle, and then you have to set the render mode, and on the first cycle you have to select pass, and if you do this it'll show up properly in game. Then you can roll over to your sources and select both textures. You want both of them to only take up half, or combined, make sure that they take up the full 4,000 kilobytes or 4,000 bytes of TMEM. So I have a few different examples shown here, and I have them split up just by types. So on the left here I have 2 RGBA multi-textures. I have 2 RGBA with an intensity texture in the middle, and I have 2 color index multi-textures on the right. When you do a color index multi-texture, you have to use the same texture twice. You can see that here, I'm using the same texture twice. If you do this, it will work. If you don't do this, you're gonna break something. And this is how they look in game. So a pretty cool thing with multi-textures is you can scroll each tile independently. So we can see I'm scrolling just one in the middle. I'm scrolling both of them in different directions on the left, and I am scrolling both of them in the same direction but at different speeds on the right. And these can create a bunch of different cool effects. I've tried to kind of cover the space of what you would use multi-textures for in these previews, though getting used to them is getting to know color combiners, and it's a bit of finicky. It's a bit of work to get used to them. But feel free to just use these as sort of inspiration for what you can do. On another note, this is what a broken multi-texture looks like. So this is a color index multi-texture that I haven't multi-textured with itself, and so it looks incredibly broken. This is not how it's supposed to look. We can show you in Blender what it's supposed to be, and that is this. So you get nothing really close to what you started with at all. It just doesn't work. So that about covers it. That's about everything you could reasonably do with textures and the different options available. If you have any specific questions about how to do any of this, or questions about something I haven't covered, leave a comment, and be sure to check out the other FAST64 and SM64 hacking tutorials. There will be links in the description. Peace.